All right, I'm going to make a video of these, the first 5 sets. You don't have to listen if you want, but the other 5, the last 5 sets, I already posted in the what's called from the other day in the Google Classroom. So the best way to do this is just go. Remember this. The deal is that so you're going log base 2 of 32 equals x, right? So you're saying really 2 to the x equals 32. So if you rewrite 32 as a power of 2, it's just 5. So x equals 5. So that's it. So your answer is just 5. Because 2 to the 5th equals 32. That's that one. This thickness. Log, same idea. So it's a little trickier. So log base 4 of 1 over 64 equals x means that it's always this to the this equals this. So 4 to the x equals 1 over 64. So what you really want to do, the easiest thing is to reorganize that right side so it's a power of 4. So I'll do that in 2 steps for you. All right. So first I'm just going to write it as 1 over 4 to the 3rd. Because 64 is 4 to the 3rd. So I'm really close now. So then if I just make this exponent negative, that flips it to the top. So this becomes 4 to the negative 3rd. Negative 3rd. So then we have, if we bring it back, the purple, and we have 4 to the x equals 4 to the 3rd. So then clearly, x has to equal negative 3. And that's it, negative 3. All right, so pretty straightforward. That's the second set. Third set. Express it given as an integer or as a fraction in simplest forms. Okay, it's kind of ugly, but it still works the same way. So we say this equals x. So we get 7 to the x equals 1 over the 5th root of 7 to the 6th. So our job right now is to rewrite this thing as a power of 7. All right, so the first thing I'm going to do is just put this 5 under this 6. When you write the exponent as a fraction, the top number is a power, making it bigger. The bottom number of the fraction is a root, making it smaller, so to speak. All right, so we're going to go 1 over 7 to the 6th fifths. All right, so I'm very close now, actually. I just need the 7 to go to the top. In order for the 7 to go to the top, I'm just going to make this exponent negative, and that flips it magically to the top. 7 to the negative 6 over 5. And now, we're all matched up. So what looked like terrible is really not so bad. 7 to the x equals 7 to the negative 6 fifths. So this x has to equal this negative 6 fifths. That's the only way that equation can work. So your answer is just negative 6 over 5. So these first 3 sets are all the same. Let's see. That was the 3rd set. Then we're on equations. All right, so write the logarithm equation as an exponential equation. I think what they want here is, so again, it should be the same thing. Should be this to this equals this. This one I might have to put. So 2 to the 1/3 equals the 3rd root of 2. Write the logarithm as an exponential equation. I think that's all they want. 2 to the 1/3 equals the 3rd root of 2. 2 to the 1/3 equals the third root of 2. Yeah. All right, so you just write it. You're not solving anything in this one. You're just rewriting it as an equation. All right, so it's a different equation because the first problem was just written as a log, and you're transforming it into an exponential equation. And the last one, really, these, by the way, these ones are kind of warm-ups. These type are warm-ups in order to get to the last 5. Because this, you're not solving anything. Same deal here. Also, this you're writing it as a log. Okay. So what are we doing with this? Write the exponential equation as a log equation. So the log, so we could write this as a log. So the log of base 5 equals -2/3. Third root of 5 to the -2/3 equals 25. I might be wrong on this one. 5 to the -2/3 does not, the third root of 5 squared does not equal that. That's wrong. 5, let me pause this for a second. I don't want to take too much time.